All right, here we go. Now, let's get why is the ocean salty. Remember yesterday we were trying to talk about why is the ocean salty, but the rivers and the lakes are not. We did our little experiment, and it showed that water is getting pulled from the soil, and so the moving water is bringing salt into the ocean. That makes sense because ponds then are not this, there's nothing to move against the bottom of the pond and rustle up all of that salt, right? Because the water in a pond or a lake is just still. But our rivers are moving, and so if they're constantly grabbing salt, but the salt is never staying in that one place, right? The salt is constantly like in movement to the ocean, but still, the closer you get to the ocean, it would make sense that that water should be salty. So let's watch Mystery Doug and find out why not. Oh, I've got to mute. Hang on. I'm sorry. Hang on. Let me mute.
Can someone turn the lights off? Yeah, I will. Oh, that will.
Doug, I didn't grow up anywhere near an ocean, but now as an adult, I live not far from one. That's the Pacific Ocean behind me. And I can tell you, if you've never been swimming in the ocean and accidentally gotten a mouthful of ocean water, it's so salty tasting. Now, it's never a great idea to drink any kind of water directly from an ocean or lake. There can be germs in it, but you can try ocean water for yourself at home by taking a few teaspoons of salt and dissolving it in a glass of water. Give it a try. Ugh. Someone named Allie has a question about the ocean. Let's give her a call now.
Hi, Doug.
Hi, Allie.
I have a question for you. Why is the ocean salty?
That's a great question. One thing that's really weird is why the oceans are salty, but other water, like lakes and rivers, aren't salty at all. You might know that we call the water in lakes and rivers fresh water. Not that you can drink it directly. You still want to boil it or clean it before drinking. But water from lakes and rivers doesn't taste salty the way the ocean does. In fact, when scientists are studying any of the water that they find on Earth, that's one of the first things they do. They figure out, is it salt water, like from the ocean, or is it fresh water, like from lakes and rivers? So why is the water that's in the ocean different from the water that's in lakes and rivers? Why is the ocean water salty? Did a bunch of salt somehow get dumped into the ocean or something? Do you have any ideas? Why do you think the ocean is salty, but lakes and rivers aren't?
Okay, so we did talk about this a little bit yesterday, or a lot bit yesterday. Hang on, Zeke wants to say something.
So yeah, so I have a connection. My brother, when he was little, like 5, he used to say that Indians put salt in the ocean.
When Zeke's little brother was little, he would say that the Native Americans just dumped a bunch of salt in the ocean, and that's how it got there. All right, Lily.
Well, I was just thinking about it because the ocean moves like really fast, and the rivers don't really move that fast. They just kind of go slow. No.
Okay, so Lily's saying, okay, when she's been to the ocean is like in this constant back and forth motion. The tide's coming in, the tide's going out. Waves are crashing on the shore. Waves are sucking back out because of the undercurrent. So there's like this constant back and forth and back and forth. And so if you think about it, there's a lot more movement because the movement's going both directions in the ocean. And in a river, it's just a slow, steady movement in one direction. So is it as likely to rustle up all of the salt and minerals and things in the soil if it's just a slow, steady movement as opposed to the constant back and forth that's in the ocean? That makes sense. I like that. Kaylee.
Kind of like what Lily said, how like the water goes back and forth. I I don't know if this is correct or not, but maybe it has something like to do with the sand, like when it goes like onto the sand and it like could bring it back in the water, and there's maybe something in the sand that makes it like salty.
Okay. So, and that was kind of like what our experiment yesterday showed, that there is salt and minerals and other things in the soil and in the sand. And so as it's pulling that back out, and as rivers and streams are running into the ocean, they're pulling some of that salt and minerals from the soil into the ocean. Josie.
It's not really a question, but it's like a cute little personal thing. So, whenever I was 3, we went on our first vacation. It was a Disney cruise, and while we were at the beach, they said I kept on drinking the water because I loved how salty it was. And they said that I just drank so much and they had to like stop me. And there was even on a video, it was like me and my sister saying how we liked it. And on the video, I was like, I love it. It's so salty.
That's awesome, Josie. Yeah. Yeah, when you're swimming in the ocean, you definitely like, you taste it because it gets on your face and whatever. And then sometimes a wave just smacks you in the face and you're like, oh yeah, I have salt water in my mouth. And I think it's super gross. I'm kind of like Mystery Duck. Blech. Yeah. I don't even really like to swim in the ocean because it like the water is sticky and then it makes your skin feel sticky after you've been in it. I would much rather swim in the pool. Okay. One more thing, Zeke, and then we're moving on.
Okay, so I think, so yeah, I hate when the salt water gets in your nose.
Salt water in your nose burns, yes.
Yeah. Okay, so my thing is, I think that Lily's theory is incorrect, that the ocean moves fast and the river moves slow. Because the river actually moves really fast. Yeah, like
Zeke said Lily's incorrect because some rivers do move really
no,
fast.
they do. Some are in rivers. They have undercurrents. They go really fast.
Good call, Joes. All right, so there's a showdown in the face-to-face room, Zeke versus Lily.
Head to head.
I can't wait to find out who's right. All right, Macy, go ahead. How does the salt get in the dirt anyway? We've already learned this.
It's a mineral.
Okay, some of it we haven't, how do the minerals get there? Some of that we haven't learned, which is the geosphere and the rock cycle, okay? So that's coming up. But some nutrients and things that are in the soil, we do know how they got there. What have we learned so far that taught us how do some nutrients get into the soil? Fiona.
Some nutrients get in the soil, like when a plant dies or something, then all of the nutrients which were in the plant now go down into the ground for other animals and plants to use.
All right, perfect. What is that fancy science word that goes with what Fiona just said? When a plant or animal dies and it goes down into the ground, Riley, what's that fancy science word?
Isn't it decomposing?
Decomposition, yes. So, all right, let's find out what's going to happen. So decomposition and then also rock cycle helps things get salty in the soil. Moving water's pulling that salt into the ocean. I'm answering the phone. Hello? All right, Macy Hodge, ready to leave. Thanks. Bye, Macy. We love you. Okay, here we go. We're going to focus, though.
So why does the water in the ocean have salt in it? I have to tell you, this is a tough mystery to solve. For a long time, very few people had any ideas at all. But today we do have some ideas based on clues that people like scientists have noticed and discovered. Scientists have developed special tools and equipment that they can use to measure very small amounts of things. And they discovered something really surprising. Even though the water in lakes and rivers is what we consider fresh water, when they tested the water and checked very carefully, they found out that this water actually does have a teeny tiny amount of salt. Not enough to where you'd be able to notice it if you tasted it. But the water in lakes and rivers is a little bit salty, just a little bit. In fact, every place they look, it doesn't matter if it's the tiniest pond or stream, there's still a little tiny bit of salt in the water.
Right? Josie.
I was gonna say it's probably like a little bit of both because of it's going to have more salt, I guess, because at my grandparents' house they have a little stream behind their house, and whenever it rains, it gets super fast because of the small currents. Maybe whenever it's like at some points it's got more salt in it than others, and I guess it's whenever it rains pretty hard.
All right. I think that's a good theory. Okay. So, yes, usually streams and rivers and things move faster when it has rained or there's like snow and ice that has melted because there's more water being added. And so it is going to start flowing faster. All right, Sean.
This just happened yesterday. So, when it rained, there's a lake. I mean, where it is. We call it the bridge. And like, there's just a big lake, and it just flooded really high, and it covered that whole entire like subdivision. Yeah.
All right, so Sean said he just saw like one of the lakes yesterday around where he lives kind of raised up because we have had so much rain the past couple of days that it flooded up and covered up a little bridge or whatever. Okay, let's keep going.
There's one exception, and that's this: rainwater. When it rains, that water, the water falling from the sky, has no salt in it at all. Even rain that falls on the ocean, there's zero salt in the raindrops. So rainwater is 100% completely fresh water. But here's the thing. Scientists discovered that once rainwater hits the ground, like when it starts to form puddles or when it trickles down into streams and rivers, that's when it starts to become a little bit salty. So then there must be something about the ground itself which makes the water in lakes and rivers become just a tiny bit salty. And there is. Geologists are scientists who study the rocks and soil that the ground is made of. They've been able to figure out that most rocks and soil contain tiny amounts of salt. When rainwater lands on the ground, it absorbs some of that salt. As that rainwater trickles into lakes and rivers, it carries this salt with it. This is why water in lakes and rivers has a little tiny amount of salt. But rain itself, when it's falling, has no salt, since it hasn't come in contact with the ground yet. But then why does the water in the ocean have so much more salt than the water in lakes and rivers? That's the big.
Zeke's about to wave his arm right off his body. Zeke.
Okay, so this isn't about like the salty ocean, but I just thought of something. If the rainwater is not salty and it's clean to drink, and if the lakes and rivers are a little bit salty, what about spring water? Because spring water is clean and it's ready to drink, and it comes through the rocks. That's what cleans it.
All right, Zeke wants to know about spring water from like a freshwater spring. We will have to research that separately. I doubt Mystery Doug addresses that.
So does it not have salt in it? Because it goes through all the minerals that clean it. That's what makes it clean.
We will have to research that separately. I don't think Mystery Doug is going to address that, but we can look it up. That's easy enough to do. Grace says she smashed her face with water when they went to Dolphin Island. You guys are smarter than Doug all day, every day. We should just start sending Doug all of our questions. Okay, here we go. More, let's find.
A question that scientists who study the ocean still aren't completely sure they know the exact reason. But if you look at a map and you trace your finger along the many rivers you see on the map, you can see that most rivers and even some lakes connect to the ocean. And since rivers and lakes are located on the continents or land, which is higher up than the ocean, the water in the rivers and lakes usually flows down into the ocean. Even though river and lake water only carries a tiny amount of salt, if that water's been flowing for years and years down into the ocean, all that salt that it does carry just keeps getting added to the ocean over and over, where it probably never leaves. We think this might be one big reason why the ocean is so much more salty than all the other water on Earth. That's all for this week's question. Thanks, Allie, for asking it. The world is filled with incredible wonders. Before you vote on next week's question,
Okay, so now we've got most of our question answered about that. Turns out that in the Leek versus Zilly, the Zeke versus Lily challenge, the truth was kind of in the middle. Turns out that everything's salty, just not salty enough for us to taste and determine it. Lights. Now we're in our science books now. And we are on page 220. Science book 220. 220.
Hey, Miss Fab, I have a question. So, doesn't the water that goes in, so like it how the water ends up in the ocean because of the water cycle. So like doesn't the water that goes in the rivers, doesn't it start in tiny streams that come from the top of the river?
Yeah.
From the melting snow.
Yeah. All right, guys. We are
On 220.
on page 220.
What about 220?
Okay, 220. And you have a worksheet called Water Ecosystems. Whether you are Seesaw, do you have that? Virtual friends, do you have this Water Ecosystems page? Okay. Be looking at these questions. Do you notice that at the top of the Water Ecosystems worksheet that it has water ecosystems? Use your textbook to help you fill in the blanks. And then it says, what are water ecosystems? There's like a heading. And you might notice that that heading matches this heading in our textbook we're about to read. What are water ecosystems? So I don't know. It's just me. But I'm thinking that questions 1, 2, 3, and 4, the answers are probably going to be in the section that we're about to read. So we need to be on the lookout for the answers to these first 4 questions. Would probably be super easy for you to fill these out as we go. Am I going to stop and tell you the answer?
Yes, we are. Okay.
But could you be listening and looking and filling them in as we go, and it would save you some time at the end of today when it's time to do your worksheet? Probably a really smart idea. Okay, so for example, the first one, let's be on the lookout. There are freshwater ecosystems and some other kind of ecosystem. Okay, probably the opposite of freshwater, but that's just me. Okay, so Lily, yes ma'am.
I think I know the water cycle because you said we'd have to teach it to you today.
Oh, Lily says she remembers the water cycle and she's ready to teach it. We're going to save that till tomorrow because Mystery Doug took longer than I wanted. So we're going to do water cycle tomorrow. Review water cycle. And Lily's first on deck to try and teach us the water cycle then. She called dibs. And if she screws up, then somebody can save her. All right, here we go. What are water ecosystems? We're going to have to kind of move through this quickly. So be looking at the questions on your worksheet and ready to fill them out. Most of Earth's surface is covered by water, but all water is not alike. About 97% of the world's water is salty ocean water. 97%, that's almost all, is ocean water. That's a lot. The other 3% is fresh water. Fresh water is water that does not contain salt or is very low in salt. Fresh water is the water you drink. Freshwater and saltwater ecosystems, wink, wink, are organized in similar ways. The organisms, I didn't tell you, what are you talking about? The organisms in water ecosystems are divided into 3 main categories. Plankton are organisms that drift freely in the water. Plankton, that's plankton. They are not able to swim. Some plankton, such as diatoms, are producers, and others are consumers, such as some animal larvae. The second group includes larger active swimmers in a body of water called nekton. Fish, turtles, and whales are all nekton. So plankton are little guys that just float along. They can't control where they go. They're just floating. They're at the mercy of the currents and the ocean water and whatever. And nekton are the bigger guys, fish, turtle, whales, all of the guys that we think about as the ocean creatures, okay?
Blue whale. We missed that. On number 2 on the top, what is that blank on the top? Because it has
Just said it.
Like you have the answers to number 1 and 2 at this point. All 3 of those blanks. All right. The third group, organisms that live on the bottom of a body of water, are called benthos. Many benthos are scavengers or decomposers because they feed on the material that floats down from the shallower water. Some benthos, such as oysters, fix themselves to one spot. Others, such as worms, burrow in the sand. Many, such as lobsters, walk about on the bottom of the body of water looking for food. So they're scavengers. They're eating on all the little dead stuff that floats down to the bottom of the ocean, okay? Benthos, many body and living creatures are scavengers or decomposers. All right. Now you've got the answer to number 3 if you were paying attention.
I did.
Like land ecosystems, biotic and abiotic factors, and we didn't talk about that, but biotic means living factors and abiotic means non-living. So living and non-living factors determine the types of organisms that can survive in water ecosystems. Unlike land ecosystems, water is never a limiting factor. However, the amount of light, dissolved salt, and dissolved oxygen are important. They can affect the types of organisms that can live in water. So if you go just under the surface of the water in the ocean, it's still pretty light there, right? But if you go deeper and deeper and deeper, what happens to the sunlight?
It gets darker. That's why
Darker.
angelfish has the lights.
Right, it gets darker and darker and darker. Sean said that's why I've seen divers have like the little like lights on their heads or whatever, and like the scuba. And then there's even that one type of fish, we see it in like Finding Dory, that has like the little light that hangs on its head. Yeah, that's actually like a real type of fish. He needs that light because he's down deep. Okay.
Did we?
All right. And the amount of salt. We just learned that the amount of salt can be different depending on which parts of the ocean or which parts you're in. So, or how deep you are. So that's going to affect what kind of creatures can live there. Some creatures are built to handle salt better than others. Okay. Little sunlight is able to penetrate to the bottom of a body of water. The water gets cooler and darker away from the surface. Shallow water allows more light to penetrate. For this reason, producers that require light for photosynthesis are usually found on the surface or in very shallow water. These same producers release oxygen during photosynthesis. Water can also pick up oxygen from the air. So little bubbles of oxygen can get picked up. Think about the ocean. It's constantly like trapping, as the waves come up, it's trapping oxygen as it's...
And fish when they breathe.
Okay. So surface and shallow waters tend to have more dissolved oxygen than the deeper water. The oxygen and nutrients from producers enable more organisms to live in the surface waters.
Did we do them? Did we find
All right.
Did we find number 4 yet?
I did.
I did.
Release the... Yep.
We did?
Yeah.
What was it?
All right. So now we're at the... Well, you got to find it on your own. If you missed one, you'll have to go back at the end and try and find it and use your headings. All right, we're at the next heading now. What are freshwater ecosystems? Not all freshwater ecosystems are alike. Rivers and streams are running water ecosystems. Lakes and ponds are standing water ecosystems. Does that make sense? Rivers and streams, Sean, honey, I know you're working on it, but lakes and ponds are standing water, meaning the water doesn't move. Rivers and streams are running water that are moving, okay? Swamps, bogs, and marshes are freshwater wetlands. Running water ecosystems, here we go. Organisms, let's see here, moving bodies of fresh water can vary from small, fast-moving brooks to large, slow-moving rivers, like Lily votes for. Faster moving bodies of water tend to have more oxygen because air mixes in as the water flows. Other nutrients are washed into the water from the land. Organisms that live in fast-moving streams or rivers have adaptations to prevent them from being swept away. Some grow attached to rocks. Others, such as salmon, have strong muscles that enable them to swim against strong currents. You have the answer to number 5, but it didn't actually say this word. You have to infer it. So thinking about number 5, organisms in running water ecosystems are adapted to how it talked about different types of running water. It talked about fast moving brooks and slow moving rivers. So are adapted to how okay. All right. Slower moving waters have less oxygen and are less dependent on the land for nutrients. More producers, such as algae, are able to survive in slow moving water. Mussels, minnows, and other organisms can also live here. All right. Standing water ecosystems. Typical freshwater lake or pond is divided into 3 zones. The shallow water zone along the shore is where most of the organisms live. Cattails, sedges, arrowgrass, and other rooted plants grow here. So plants like we think of, normal plants that have roots that go down in the ground, they're at the shallow water along the edges, along the banks of the pond or lake, okay?
What is the shallow water? Standing water.
Of the
Shallow water.
Okay, these plants are home to a variety of microorganisms. They are eaten by animals such as insects, worms, tiny fish, insect larvae, and crustaceans. Like, you were just talking about crustaceans, the little guys that you eat, and they're in crawdads. Crawdads, that's what I was trying to think of. These animals are eaten by larger organisms that include frogs, birds, and small sunfish. Top predators such as heron, bass, and turtles eat the small predators.
And we eat them.
The open water zone includes the water that's away from the shore. This zone may be too deep for rooted plants to survive. Producers such as algae and plankton float near the surface. Nectins such as trout, whitefish, and pike are found here. The bottom zone is below the open water zone. The little light reaches the bottom, so producers cannot grow here. As a result, there's very little oxygen. Food must drift into this zone from other zones. Benthos, including worms and mollusks, are found in this zone. So if you look at the picture at the bottom, it's showing you fresh water. It's showing you like a little pond, or not a little pond, this is a lake. Shallow water is right where you could walk out and still stand like maybe knee high. And there's a bunch of little fishes, lily pads. There's that like grassy stuff that grows in the water, cattails. Okay, you go a little deeper.
What is the bottom zone?
The bottom zone is called the bottom zone.
Yeah.
It's literally at the top paragraph of
And you could just
page,
look at
the bottom zone. And it's the stuff down at the bottom where the benthos live, the scavengers, and they're getting all the little dead stuff that floats to the bottom, right? There's not a lot of light down there because it's too deep. And open water is where you're doing your jet ski or your tubing or whatever, like out deep where you can't touch the bottom. Okay.
I love tubing.
It's not something that I do a lot of. I've done it a couple times,
I never did
but, and you may have never done it. That's okay. But you can picture what I'm talking about. Open waters where you can't touch the bottom.
Wait,
You're out deep. Okay.
have you ever gone wakeboarding? Well, it's like
All right. Freshwater wetlands. Wetlands such as marshes, swamps, and bogs are regions that are wet for most of the year. They are found in areas between land and water. Here, plants must be adapted to water-soaked soil. Grass-like plants, moss, and some shrubs are found in the wetlands. Beavers, muskrats, otters, and fish live in wetlands. So that makes me think of like Florida. There's a lot of swampy areas in Florida, like where the alligator, Louisiana. Those are kind of marshy, swampy lands. Anywhere around, like along the Gulf of Mexico, down in those southern states, is all kind of swampy, marshlandy area. All right. For us, flip over. We are ready for what are ocean ecosystems, our next heading. Okay. Now, we're done with our freshwater. We're moving into the salty water. Ocean ecosystems. Like pond and lake ecosystems, oceans are divided into zones. The shallowest part of the ocean ecosystem is called the intertidal zone. And you can look up at the picture. Again, that looks like the part of the ocean that you could like reasonably swim in, walk out in, play around in, okay? Every day, the pull of the moon's gravity causes ocean tides to rise and fall over the intertidal zone. It is covered by water at high tide, and at low tide, the organisms of the intertidal zone are exposed to the air. So the intertidal zone is that area where the tide comes in and goes out. So depending on the time of the day, if you're in the intertidal zone, you might just be standing on sand if the tide is out. But if the tide comes in, you might be knee deep in ocean without even moving. That's the intertidal zone. Think about that, intertidal zone.
Oh, I heard that.
Okay? So the tide coming in and out, that's the intertidal zone, the area that's sometimes covered by the tide and sometimes not. Tide is in the word. It makes sense, right? Okay, that can help us remember that one. Okay? Beyond the intertidal zone, we're going out a little deeper, is the neritic and the oceanic zones. In the neritic zone, the key resource is sunlight. Producers grow in huge numbers near the surface water where sunlight can still penetrate through. They attract small fish, animal-like plankton, and whales. These organisms, in turn, attract larger organisms such as seals, sea turtles, jellyfish, and other large fish. So the neritic zone, if you look in the picture, it looks like where all of the, oh gosh, what's that stuff called?
Otters. No,
Coral, thank you. My brains are a marshy wetland right now. Neritic zone, it has the coral, it's got a lot of the fish and things that we see, the smaller guys, okay? Not the big whales and things, okay? But they need that sunlight. These are the organisms that still need sunlight because once we start getting deeper, the sunlight's going to start getting more and more scarce. The oceanic zone is divided into the bathyal zone and the abyssal zone. Okay? So oceanic, that means we're like out in the open ocean. Open ocean, okay? And it goes divided into the bathyal zone and the abyssal zone. Bathyal zone is home to many consumers such as sharks, but few producers. So there's not a lot of plants in this bathyal zone. Looking at the picture where the bathyal zone is, why do you think there are not a lot of producers or plants in that zone?
Because it needs
Parker.
It's really deep.
Well,
It's really deep. Why would deep be a problem?
But there's no sunlight and they can't swim.
Okay, there's no sunlight because we're getting deep. And is there anything for them to like latch onto and root onto?
Oh, those things with the spiky things.
Okay.
Sea urchins.
Sea urchins? No. They're a type of fish though. They're not a plant. I think. Or they are in the coral. Oh no, they're in the coral, which is in the neritic zone. Okay. Bathyal zone, we're past the coral. We're out deep, like open ocean. And so when we're in the open ocean, the oceanic zone, the top half of it is the bathyal zone. Okay. Which is where the fish, the whales, all of that are. But there's not a lot of plants. There's not a lot of sunlight out there. And the deeper you go, they can't form roots. They can't stay put. The ocean water's constantly moving. There's no way for them to plant themselves.
I'm gonna go ahead.
Okay. Marine mammals also live here, but they must stay close to the surface so that they can breathe. Farther down, way deep, is the abyssal zone. Here it is darker and colder than the other zones because the sunlight is completely blocked. Without light, producers cannot perform photosynthesis. Without producers, the consumers can't survive. Organisms in this zone tend to be scavengers or decomposers. They live on nutrients that float down from the other zones. So again, it's all those guys that are feeding off of all the dead stuff that just makes its way down to the bottom. But that's like crazy deep. I'm talking so deep that the pressure is immense. We can't go down there without special gear. Like you can't just scuba dive down that low. Okay, you got to be in a submarine. You got to have pressurized suits, and even then, you can't be down there for very long. Okay, and then you've got a little chart that shows a little bit more detail. We're gonna keep moving. All right, saltwater and freshwater meet. The boundary where freshwater feeds into saltwater is called an estuary. Estuaries are unique ecosystems that are part saltwater and part freshwater. Like intertidal zones, estuaries change with the tides. When the tide comes in, estuary water becomes more salty because when the tide's coming in, it's bringing more ocean water with it. So that makes sense. It's going to be more salty. The tide also brings in nutrients from the land. When the tide runs out, the estuary becomes mostly freshwater and the wastes are flushed out. Estuaries usually contain salty marshes. These boggy areas are covered with grasses and other marsh plants. The marsh grasses and surrounding water provide habitats for a wide variety of organisms. Large numbers of shrimp, oysters, clam, and fish live in estuaries. Many ocean fish return to estuaries to lay their eggs. Why would ocean fish come to these estuaries to lay their eggs instead of trying to do that in the ocean?
So they don't get eaten?
So they don't get eaten. Why? Fiona, why do you think?
Why turtles lay their eggs not in the ocean?
Mm-hmm.
Because I don't think quite the baby turtles don't know exactly how to swim once they're frozen. So they live in the sand, and then every so often the mama come back and check them.
Okay. He says maybe it's because.
Well, the estuary's in the water. That's not what turtles.
She said maybe. Okay, so turtles aren't laying their eggs in the ocean because they have to come up on the sand because the baby turtles need to be on land first.
No,
they
it's
can't.
an instinct for the baby turtles.
All right, Kendall, why do you think?
I think that the turtles lay their eggs because the babies can't breathe in the water while they're in the eggs, and the eggs could float away, and whenever the babies hatch, they cannot swim yet.
Okay. Eggs would float away, Kendall says, in the open ocean. Josie, what are you thinking?
Yes, it doesn't it?
A lot like Kindle, like if they just laid them in like completely in the ocean, then they would just like be sloshed around and just be drifting. But then they could eventually be into the ocean, but they just not be as like splashed around, I guess.
Okay. Yes.
Ooh,
All right.
What?
Okay, Jay.
Turtle eggs, if they get too wet, they never hatch.
Good to know.
We can pressure. Like it can crush the egg.
Okay. In the ocean, things would keep floating down, 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 and then the pressure would possibly kill them. Okay, let's keep reading. Countless insect larvae, young fish, and tiny invertebrates begin their lives in the calm, protected waters within an estuary. Does that help answer that? The waters are not as, like Kendall and Josie said, the waters aren't moving as much. They're not just going to drift away. And the waters are more protected. They're not going to get eaten from all of the different things that are out in the open ocean, okay? Larger organisms, including egrets, herons, which are both types of birds, frogs, turtles, muskrats, raccoons, otters, and bobcats, feed on these smaller consumers. So even though the fish come up into the estuary and think it's safer, there's a ton of predators still in the estuary too. Salt marshes within estuaries perform several special functions for a coastal region. They act like a sponge during storms to soak up excess water. The roots and stems of marsh plants also act as filters for river water. Yeah, Greg.
I kind of see what it is on 15 now, but after it says wetlands protect coastal regions during, does that mean blank?
Mm-hmm.
Because I don't see the line there.
Oh yeah, there's a line there. During like, bye. Okay. The roots and stems of marsh plants also act as filters for river water. The grasses in salt marshes slow the water down and trap nutrients and pollution. The water that then flows into the ocean has been cleaned. All right.
Oh, I got it.
So you should be able to answer all of the questions on your worksheet at this point. If you missed one or two, you can use those headings to go back to that section and try and find it. Hang on 2 seconds. This is for a grade, this worksheet today. So do your best to make sure you are finding that information from the text. All of it is in there. You just got to find it. Other questions you have about saltwater, freshwater ecosystems, anything else you guys have questions about? Tomorrow we're going to talk about the water cycle and how then the hydrosphere is interacting with the other spheres.
We do 16 too.
Josie, yes.
This isn't about science. It's about writing, but so once we're done with science and stop recording, I'll ask.
Okay. Anybody else have anything science before I stop recording? Why is it not giving me my bar?
Hey guys, what you guys doing?